Alright, I'm going to roll here, so I'm going to go on and do problem 5.12, even though my dinner's not done. So, these are some of the easier problems that we're going to have to do in the homework. It's right below the one that you actually have to do for your assignment about the linear, stretching and compression of things. So we have a steel wire that's 300 feet long. That is suspended from, some rigid business up here that will, whatever, rigid business. 300 feet wire. It is, diameter is 1/8 of an inch. 125 inches. And the weight, we'll call it W, is 0.042 pounds per foot. So, the question is the maximum tensile stress due to its own weight. Find max sigma. So, first the question is, where is the maximum sigma? Is it here, somewhere in the middle, or here? And it should be immediately obvious to you that right here, it's not supporting anything. But right here, this little bit of wire is supporting the entire length of the rope. So the maximum stress is going to be right where it's mounted. We know that stress equals the force over the area. So first, let's find the area. Area equals pi. Let's see, we have diameter. So I'll use pi d squared over 4. Now, this is something from middle school, but I still see a lot of people screw this up. So make sure you either use pi times diameter squared over 4 or pi times radius squared. Remember the difference between radius and diameter. So this is equal to 3.1415. I'll be honest with you, I know an embarrassing number of digits of pi, like 80 or something like that. 3.14159 something 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 times 0.125 inches, all that squared, over 4. Go to the calculator and find that out. A equals 0.0122 inches squared. That's the area. Now we need to find the force. The force is 300 pounds, or 300 feet worth of rope. So we know the weight. So we'll have 300 feet times 0.042 pounds per foot. And all that business. Equals 100. Wait. Yes. Okay. 12.6 pounds. So there's the force. So sigma is equal to 12.6 pounds over the area, 0.0122 inches squared, which equals 1,032.8 pounds per square inch. Now, I've talked about this before, but make sure that you are consistent when you're using KSI, which is kips per square inch, and pounds, which is or PSI, which is pounds per square inch. Just look at your previous math and make sure you write down the correct thing here. This is 1,000 psi, which is it's a lot for wood. It's a pretty significant amount for plastic. For steel, it's nothing. So I believe that's the answer to sub-question A. Now sub-question B. The maximum weight that can be supported, assuming a safety factor of 3. So factor of safety equals 3, and ultimate strength of, call it sigma max, equals 65 KSI. When you're throwing around the strengths of steel and stuff like that, be very careful that you know which strength you're throwing out. The ultimate strength, like if you have stressed something anywhere close to the ultimate strength, you should probably just throw it away. For steel, that usually means it's stretched probably significantly and it won't be returning to its nominal shape, and you shouldn't design ever to the ultimate strength. Depending on your system, you should usually design to some kind of a yield strength or even a fatigue strength. But the design to the ultimate strength is a typically folly, just so you guys know. Factor of safety of 3 is pretty significant though, so if you're just hanging something off the rope once, it should probably be okay. If you're taking the load on and off in millions of pounds, the rope can actually fatigue and break still. So there's a little more soapboxing for you. That's the benefits of wine. Alright, so now we know that sigma max equals this. Let's find sigma allowable. This is sigma max divided by the factor of safety. So that'll be 65 KSI over 3, which will be 21.66 repeating KSI. So we're supposed to find the amount of weight that equals this. Now it's not clear, are they talking about number of feet or like a little brick W that they're holding on to the end of this rope? As long as you make it clear, like what kind of assumption like that you're using, either is fine. I'm going to make the assumption they're talking about some weight right here, W. So we know that sigma from the rope alone is about 1,000. And so we know that the rest of this 21.66 KSI has to come from the weight. So the stress due to the weight is going to equal 21.66 KSI minus 1.032 KSI. Notice I converted from PSI to KSI by moving the decimal over 3 spots. .634 KSI, or KSI. So this is the stress due to the weight. Now we know that stress equals basically force over area. In this case, the force is our weight, and the area is what's known. So if we're trying to find that weight W, now this is the same thing as weight over area. W would equal the sigma times A. Simple algebra, just moving the A over there. And that means we will get KSI times 0.0122 should be 251 pounds. Notice that I converted from KSI and stuff just on the fly there. Make sure you are very careful with the math if you don't know what you're doing. So, there you go. these are some of the easier problems, just the tensile stretch problems. Read through the chapter if you have any questions, and it's one of the more straightforward topics we're going to talk about. And as always, please let me know if you've got any questions. Talk to you later.